Hi guys, I'm just making another video on this all stations to central stuff, or this unit circle stuff, just because I feel as though in the notes that you're getting into your book, I don't feel as though the video explained this stuff, like the reasoning behind these values very well. So I wanted just to quickly go over this to show you why sine theta equals 0, why cos theta equals 1, why tan theta equals 0. It's really important to understand it. Okay, so let's just go through each of these different angles one at a time. You could put these into your calculator, literally, like you could put sine of 0 into your calculator and it'll tell you that it equals 0. But I need you to understand why it is, and it's all to do with the unit circle. Okay, so with this unit circle here, people, so I need you guys to really understand that if I zoom in nice and large, it's all about making some sort of angle with this line right here. It's all about making an angle with that line. So for example, if I make a 45-degree angle, or let's make a 60-degree angle. So if I make a 60-degree angle here, I need you guys to be aware that when you make this 60-degree angle, it will hit the unit circle right here. So this is a really important point that really affects your answers for sine, cos, and tan, what this point is. Okay, so let's say that point is, I'm going to literally guess, let's say that has an x value. So its x value would be right here, because it's straight underneath the point. Let's say that's about 0.45. It kind of looks close to halfway, so I'm going to say its x value is 0.45. And let's say that its y value, so that's its y value right there, that looks pretty close to 1. Let's say that's 0.8. So that's that point. I'm only guessing those. And I'm guessing that angle is about 60 degrees. So literally what the unit circle is pretty much saying is that you also have to remember that sine of theta is equal to y, that cos of theta is equal to x, and that tan of theta is equal to y over x. They really emphasize this in the videos. So these formulas here help you out with finding things like cos of, well, let's start with sine actually. So sine of this 60 degrees that I've got here. So without using a calculator, we can use this unit circle to figure out things like sine 60. Okay, so it's about doing some of this stuff without using a calculator. It's really important that we're not just relying on calculators to do this sort of stuff. So this is how we kind of use it. Like, this is the sort of stuff they would have done before calculators were around. Okay, so what they do is they notice that this is the point that is hit. So they've used the fact that sine of theta equals y. They've used this one here. And they've thought to themselves, okay, well, sine of theta, our theta here is 60, and it's equal to the y value. Well, look at your y value. Your y value is this one right here. That's your y value of your point. So literally that is going to be equal to this 0.8 because it was equal to y. So you just think, what was my y value? It was 0.8. So that's pretty much, they've given it to you straight away. Now, I've only guessed, so that won't be the right answer, but that's pretty much the general principle. They can also do it for cos of 60. And cos of 60 is equal to the x value, and that's equal to this 0.45. So they pretty much figured out values for these cos of 60s without a calculator. But obviously you need to do your unit circles perfect. You need perfect coordinates. They also could do it for tan. Tan of 60 is equal to the y divided by the x. So our y was 0.8 and our x is 0.45. So whatever that equals is your answer. So that's the idea behind the unit circle. But we want to just do it for some easier sort of points. We want to do it for angles not like 60 but more like 90 and 0, etc. So these are the ones that I'm getting you to write into your book. Okay, so let's start with 0. So here is the 0 angle. Let's do it in a different color. So here's the 0 angle. It literally doesn't make an angle. It's 0 degrees. There's no angle. But look at the point. It was all about this point here. So this point right here at the end. So this one here, what's its coordinates? It's going to be 1, 0. So we can literally find out what sine of 0 degrees is. Because sine of 0 degrees, remember that sine of theta is equal to y. What's our y? Our y is 0. So sine of 0 degrees equals 0. Cos of 0, well, cos of theta was equal to x. What's our x value here? X value here is 1. So cos of 0 equals 1. And then lastly, tan of 0, well, tan of theta was equal to y over x. So our y divided by our x is 0 divided by 1, which equals just 0. So that's how we're getting these definitions. Similar sort of thing for 90 degrees and 180. Let's do 90 degrees. So let's move on. So let's do 90 degrees. So here is our 90 degree angle up here. This is the point we're dealing with. This point here is the point, it's 0, 1. That's the point. That is our y and that is our x for this point when we've got a 90 degree angle. So let's deal with sine first. So what would sine of 90 degrees be? You can do this without a calculator. And the way to do it is to think to yourself, well, sine of theta is equal to y. So for this point here, for this point when it's 90 degrees, what's our y? Our y is 1. Let's see here, y equals 1. So therefore it's 1. Done. So that's how you get this solution right here. Let's do cos. So cos of theta equals x. So cos of 90 degrees, what's our x value? Our x value is 0. Done. Simple, easy. And then lastly, tan of theta, well, that's equal to y divided by x. So tan of 90, well, what's our y? Our y was 1 and our x is 0. Really important, 1 over 0. You can't divide by 0. That equals, if you did that in a calculator, it'd come out as error. So therefore, tan 90 is undefined. It doesn't have a value. So that's why they've got this here. Let's jump to 270. So I won't worry about 180. You just got to pretty much deal with this point here, which is minus 10 for 180, and you get these. Let's deal with 270 down here. People don't seem to like 270 for some reason. So 270 is this angle here. So you're going all the way down here. See how you got a 270 degree angle there, going all the way around? Okay, so we're dealing with this point. It's all about this point. That's the point 0, minus 1. So that's our x and that's our y. Simple as that. So let's do sine of theta is equal to y. You just have to remember that. So therefore sine of my 270, what's my y? My y is minus 1. Done, easy. It's right there, simple. Cos of 270, or cos of theta has to be the x value equal to x. That's 0, because look, x is 0. And then lastly, tan of 270, so that's a 2, equals the y over x for the tan theta. Y is minus 1, x is 0, minus 1 over 0. You can't divide by 0. So that is also undefined. Look at your 360. Sorry, get rid of that. So your 360 is all the way around. That's the same as 0. So when theta is 360, it's going to be exactly the same as 0. So it literally like resets. So your values here and here, exactly the same. So 360, 0, same thing. So don't have to remember 360s. But guys, if you can remember this circle and how it works, you don't have to memorize any of these. You can just remember this circle and you can figure it out just using these points. Okay, good luck with the question.